Hi everyone, so from this video we are going to get back to divergence and curl, and with respect to that we are going to study divergence theorem and Stokes theorem. So first let's study about divergence again. So what is a divergence? So divergence of a flux density f or a vector field f, divergence of a vector field f is given by total outward flux from a closed surface per unit very small volume. This is how the divergence is given. Total outward flux through a closed surface, mark this point, closed surface, through a closed surface per unit volume. If you are talking about volume, that means it has to be closed surface only, right? If you are talking about volume, then it has to be closed surface. What do you mean by closed surface? Oh, with the help of open surfaces, you can make a closed surface, right? With the help of open surfaces, you can make closed surface, and that will enclose some volume. I can show the example here very quickly. Roughly, I will show the example. Only I will erase it up. So roughly, I am showing the example like using these surfaces. I am making this. So there are 6 open surfaces which has made one closed surface. This is one closed surface with the help of 6 open surfaces. With the help of 6 open surfaces, we have made one closed surface. So what is divergence? Total outward flux from this closed surface per unit very small volume. And from here we can get the divergence theorem. What I am gonna do, I will take dv this side and then take the integration. So from here, what do I get? F dot ds is equals to, mark this sign, closed surface, very important, closed surface. For every surface integration you cannot apply it. The surface has to be closed, then only you can apply this theorem. Okay, and that would be equals to del dot f dv. Now how we will remember this theorem, sir? So that you will be able to remember, because a lot of questions we are going to solve. And in Stokes theorem, what we are going to do, dl will be changed to ds in Stokes theorem. Okay, dl will be changed to ds, and here ds will be changed to dv. Now tell me one thing, dv is a vector quantity or scalar quantity? dv is scalar. So scalar will be multiplied with scalar only. Scalar will be multiplied with scalar only. So you cannot put curl here, because curl is a vector quantity. So what you will put? Divergence. Otherwise you will be able to remember f dot ds will be equals to del dot f dv. We will apply it again and again. So with that you will be able to remember it. F dot ds is del dot f dv. Okay. So closed surface has to be there. So f dot ds would be equals to del dot f dv. This sign is very important. You take care of that. Closed surface. Okay. So this is your divergence theorem. Now what is this point written? Very important point. Above theorem is applicable only when your vector field doesn't tend to 0 by 0 or infinity. Indeterminate form should not be there. Also infinity should not be there. In any point, at any point in the enclosed volume. What do I mean by that? Let's take an example. Let's just say this is my example. Vector f is given as x square plus x square by y square ax cap plus something ay cap az cap, something is there. And this is my enclosed volume. This is my closed surface. Now in this enclosed volume, 0, 0, 0 point will come. Say yes or no? In this enclosed volume, 0, 0, 0 point will come. Now at 0, 0, 0, what will be the value of this vector field function? At point 0, 0, 0, what is the value of this vector field function? 0 divided by 0, which is an undeterminate form. So here the theorem is not applicable. Are you getting this point? So always while applying this theorem, you need to check if there is any point where my function can go to indeterminate form. If it is going there, then I cannot apply the theorem. We will take example like that. Okay, at that time you will forget it. 99% of the students will forget that I need to check this condition as well, because in the 99.95% of the problems this theorem will be applicable, but there are 0.05% of the problems where the theorem will not be applicable. So what are the conditions? Two conditions. Surface has to be closed. First is surface has to be closed. If surface is open, let's just say I just give you this sheet, okay, and I give you a vector field and I ask you find f dot ds. This is what I am asking, f dot ds. So now I cannot apply the theorem. Why I cannot apply the theorem? Because it is applicable only for a closed surface. So, but if I have given you a cube which is made from six of this open surfaces, if I am giving you this cube and I am asking you find this thing f dot ds and closed volume, it is enclosing some volume, or I can say closed surface. If I am asking you f dot ds for a closed surface, then you can apply this theorem. Okay, so that is the important point. And secondly, your vector field f should not go to 0 by 0 or infinity. So two things you need to take care. So blindly do not apply this theorem everywhere. Okay, so we will solve the problems now. With the help of problems only you will be able to remember all these things, otherwise you will just forget. You need to find total outward flux of a vector field through the closed surface of a cylinder, where cylinder is going from 0 to height is 2 and radius is 2. Height is 2 and rho is 2. Now by looking at this question, some people will think that, sir, here he has given rho equals to 2. That means he is asking only for curved surface. How will you make a cylinder? Let's make a cylinder now. Z is from 0 to 2. Okay. This is the cylinder. So it feels like that, sir, he has given rho equals to 2. That means rho equals to 2, which will be the surface? This will be the curved surface is rho equals to 2, right? I hope you know it. Curved surface is rho equals to 2. This is your z equals to some alpha and this is your z equals to 0. This is the equation of these surfaces. I hope you know it, right? Now people will think that, sir, he is only talking about curved surface. No, but he has written no closed surface. That means he is not only talking about this. He is not only talking about this. He is talking about this as well and this as well through the closed surface. Okay, so all will be filled. So complete enclosed volume is there. Basically, I should show it something like this, that this is also filled, this is also filled, and this curved is also filled. So now I need to find total flux. So total flux I need to find from, what is the thing I need to find? I need to find A dot ds. Total A dot ds I need to find. So A dot ds I need to find from top, from bottom. This is not much clear in the statement of the question. I should have written the statement more clearly, that from upper side as well flux will pass. In the examination, if the question comes, the language will be more clear there. Okay, do not worry about that. Top, bottom and curved. So from all you need to find. So what do you know? I know that A dot ds will be for a curved surface, that is del dot A dv. Okay, what will be my dv for cylinder? What will be my dv? d rho, rho d phi and dz. So dv will be rho d rho d phi dz. Just a second. Rho d rho d phi dz. Okay, this will be dv. And what else I need to calculate? I need to calculate del dot A. Del dot A. Del dot A for cylindrical system. What is that? 1 by rho d by d rho, rho into this value, that is 1 by 4 rho square cos square phi into 1 by 4 rho square cos square phi, 1 by rho d by d phi, rho d phi, then a phi is z square and the z term is not even there. In the examination, you are not going to write these terms, right? Because you would know that d by d phi I need to do, and z square is there. That will be 0. This will also be 0. So only this term I will take care. And from there as well, I know that 1 by 4 will come out. 1 by 4 rho. This 4 is coming out. 1 by 4 rho. Cos square phi will also come out into 3 rho square. This is rho cube. So 3 rho square. 1 by 4 cos square phi is coming out. So what I am getting? So you are getting 3 by 4 rho cos square phi. Okay, let's check it back. 1 by 4 is there, rho square cos square phi. 1 by 4 is there, this rho will be there, rho cube 3 rho square 3 by 4 rho cos square phi. Yeah, this is your del dot E. Now some people will think that, sir, I should put rho equals to 2 here. Should you put rho equals to 2 here? No, you cannot put rho equals to 2. Why is that so? Because on this surface rho is not constant. You are not only calculating for curved, no, you are calculating for the complete volume. So here rho is not constant, phi is not constant on the complete one, here z is not constant. So all the limits you will put, you will not do anything with this del dot A. Now what you are going to do? You need to find del dot A dV for the volume. You can see, you can show 3 integration here as well. Okay. So del dot A, that is 3 by 4 rho cos square phi, and dV is rho d rho d phi dz, and rho is going from 0 to 2. Rho is going from 0 to 2. Phi is going from 0 to 2 pi. Phi has the complete limit. If phi is not even mentioned, that means phi is from 0 to 2 pi, and z is 0 to 2. Z is equals to 0 to 2. Just you need to take care of the calculation now, which is the biggest task for you as well, for me as well, because I also do a lot of calculation mistake. So 3 by 4 will come outward. If we see, rho square d rho will be there, rho square d rho. So it will be rho cube by 3 from 0 to 2. I am taking up the limit now. First I will take the limit of rho. Shall I solve it here? What I am doing? 3 by 4. Now rho is going from 0 to 2. So first I am breaking the limit of rho, which is rho square d rho. Then I will take the limit of phi. Phi is going from 0 to 2 pi. Here it will become cos square phi d phi, and z has no other term, so z is going from 0 to 2. Z is going from 0 to 2 into dz. Okay, now I need to solve this integration. So 3 by 4 rho cube by 3 0 to 2. No doubt about this. What is the value of this? What is the value of this integration? That is equals to pi. How did I get it? I will tell you later on in this lecture only, but here I am telling. So 0 to 2 pi. How cos square phi can be written? 1 plus cos 2 phi divided by 2 d phi. So 1 by 2 d phi 0 to 2 pi, and plus 1 by 2 cos 2 phi d phi 0 to 2 pi. So if you make the graph of cos 2 phi, here I have made, this is the graph of cos theta. Okay. So from 0 to 2 pi, it will be 0 only. This will be 0. So what you are going to get? Pi. I hope you know this much of integration. You are going to get pi here. You are going to get pi here, and this will be 2. So 3 and 3 get cancelled. What we are getting here? 4 pi, right? Is that correct? 3 and 3 got cancelled here. This is 2 to the power 2, 4 pi. This is the answer. Right? Very easy. You can solve it using top, bottom and curved as well. Like you find these separately. Have we find these separately? Yes. This kind of questions we have seen in the previous video where we found it separately. Now you can go back to the previous question. You can go back to the previous video and you can solve that problem using this divergence theorem. You will get the same answer because that was also closed surface, right? That was also closed surface. So there also you can apply this theorem. But building the concept was important, that top, bottom and curved, that separately also you need to solve. And here there was no discontinuity, right? I did not check the discontinuity, but there will be no discontinuity. 0 by 0 form will not come, infinity form will not come, right? You can see it here. If you put rho equals to 0, cos this will be 0, z will be 0, these will be 0, but this is not a undeterminate form. You need to avoid an undeterminate form, and undeterminate form can come only when 1 by rho type of function is coming. If 1 by rho type of function is coming, then you need to think. If 1 by z type of function is coming, then you need to think. Otherwise, there will be no discontinuity. In tan phi, there can be some discontinuity because tan phi can go to infinity. But if cos is there, then it can go from -1 to 1 only, and this can go from 0 to 1 only actually, because it is cos square phi. So there is no problem of discontinuity as well. Very rare that it will happen, very rarely that discontinuity problems will come, but still we will take one example where discontinuity will be there and you will be messing it up. Okay, we will take one example, probably in the next video or in this video only we will see that. Again, the same kind of problem is there. You need to pause the video and solve it on your own, or shall I give it as a homework? It is a bit different. The limit of rho is from 2 to 3, limit of z is from 0 to 5, limit of rho is from 2 to 3, and rest all things are the same. Again, you need to calculate a dot ds. So that will be del dot a dv. Okay, so you can calculate del dot a first. So 1 by rho d by d rho, rho will come, so this will be rho cube sin phi, 1 by rho d by d phi, z cos phi, d by dz, rho z. Okay, so 1 by rho 3 rho square sin phi plus z by rho. What is the differentiation of cos phi? Minus sin phi. So this sign will be minus, plus rho will come outward. So this is the answer you are getting. Let's solve it more. So 3 rho sin phi minus z by rho sin phi plus rho. Okay, so this is your del dot A. Now what will be dv? dv will be rho d rho d phi dz, rho d rho d phi dz. Okay, array, no space there. So now I am calculating del dot A dv. Limit of rho is going from 2 to 5, 2 to 3. Z is going from 0 to 5, and phi is going from 0 to 2 pi only. Phi is not even mentioned. Then this much big function will come. This function will come. 3 rho sin phi. 3 rho sin phi minus z by rho sin phi plus rho. Rho d phi dz. There is very high chance of calculation error in these kind of problems. So always you should keep on checking the calculation. Whatever the calculation you are doing, in each step you should keep on checking the calculation. Like del dot A, I am 3 rho square rho 3 rho sin phi, that is fine. 1 by rho d phi sin cos phi, cos minus sin. Okay, that is also fine. And then here rho will come outward. This is also fine. So 3 rho I will get sin phi minus z by rho cos phi plus rho cos phi. Okay, and this also I have written correctly. You will be turning pages as well, so there also you can write down some expression wrong, so that also you need to check. So these kind of questions should be solved with good amount of patience in the examination. You should not lose your patience there. So currently I am not putting the limit, so I am not writing down the limit as well. So what I am gonna get? 3 rho square sin phi 3 rho will come inside, so rho I am taking inside, so z sin phi plus rho square. Now it will be d rho d phi dz. Okay, so separately I can solve the limits now. So 3 rho square sine phi d rho d phi dz. Actually this step is needless actually. This step was needless. Now then z sine phi d rho d phi dz plus rho square d rho d phi dz. There was no use of this step, so I will just remove it off. Separately we need to put the limit. So here we are going to get rho cube by 3. So 3 and 3 will get cancelled. Limit of rho is from 2 to 3. What about sine phi? Sine phi d phi. What that would be? Basically integration of sine phi d phi. Integration of sine phi d phi from 0 to 2 pi. What will be the answer? What do you think? 0. So this term has gone to 0 now. There is no issue about this term. And what about z? Z is going from 0 to 5, but I don't care because this term will be 0 now. Okay, so I don't need to think about this term at all. Same goes for this term as well. Here also you are getting sine phi, no? In this term as well you are getting sine phi. What will happen is that rho differentiation of d rho will be rho. So rho will be going from 0 to 2 to 3. 2 to 3. Z will be going from z into dz, z square by 2. Z will be going from 0 to 5. But integration of 0 to 2 pi sine phi d phi, that will be 0. 0 to 2 pi sine phi d phi, this will be 0. So again these two terms has gone to 0. Now the final term, which is this. So rho cube by 3. Here rho will go from 2 to 3. Okay. And then phi will go from 0 to 2 pi. And z will go from 0 to 5. So what you are going to get here? What is the final answer we are getting? 27 3 cube. So that will be 27 minus 4. So 27 minus 4, 23 by 3. Is minus 4 is by 3 into 2 pi into 5. Okay, this was 2 cube actually. 2 cube is 8. 2 cube is 8. So 27 minus 9 is 8. 19 it would be. So what you are getting? 190 pi by 3. This is the answer. Okay. It feels like it was a large calculation, but here this guy helped. 0 to 2 pi 0. Complete 0. So only this we need to solve. Calculation got reduced on this step. Right. Here it got reduced. So this is the answer, 190 pi by 3. Okay. So this page is not useful. So let's see some trigonometric result because it was useful here. So let's see some results. So this is the graph of sine theta, right? This is the graph of cos theta. So if I am asking you what is the integration of sine theta d theta from 0 to 2 pi. So what you are going to do? You are going to add this area plus this area. So whatever positive you are getting, the same negative you are getting here. So answer will be 0, right? Are you getting this point? You don't even need to solve it. If I ask you from 0 to 4 pi, from 0 to 4 pi, then what will be the answer? Positive area is this much, negative area is this much, positive area is this much, negative area is this much. Again 0. So from 0 to 2n pi, if I am asking from 0 to 2n pi, the answer will be 0 only. And same goes for cos theta as well. Now what is this? Sin 2 theta. Sin 2 theta. What will be the graph of sin 2 theta? What do you think? Sin 0 is 0. Put theta equals to 0. I am making the graph of theta versus sin 2 theta. So put theta equals to 0, you will get sin 0 only. Put theta equals to pi by 4. What you are going to get? Sin pi by 2. Put theta equals to pi by 4. What you are going to get? Sin pi by 2. What is the value of sin pi by 2? 1. 1. So this is pi by 4. At pi by 2, 0. And the same graph will go like this till pi. So if I am asking you sin 2 theta d theta from 0 to pi, what will be the answer? 0. So that's why I have written n pi here. So n can take any integer value. Are you getting this point? Will you be able to think in the examination? I am not asking you to mug it up, because if you mug up, you will be forgetting it. If you have studied signal system, these kind of things you must have studied. From 0 to 2 n pi, that means in one time period. This is your one time period. Any sinusoid or cosinusoid signal in one time period will give the integration value 0. This is the time period. What is the time period of this sinusoid function? That is pi only. So in one time period, it will give you 0. If 2 time period they are asking, then again 0. 3 time period they are asking, again 0. But if they are asking 3 pi by 2, then this will be 0, but this will come in action. Okay, if they are asking 5 pi by 2, then till 2 pi is 0, but this much part will come in action in 5 pi by 2. So there we cannot apply any formula. So here n should be belonging to integer, positive integer, or negative integer will also work. So n should be belonging to integer, or negative integer also works. Minus 2 pi, that will be in this direction only. So n should be integer. Now, what will be the value of this? What do you think? What will be the value of this? That I have already told. What is the value of cos 2 theta? That is 2 cos square theta minus 1 and 1 minus 2 sin square theta. So cos square theta can be replaced with cos 2 theta plus 1 by 2, and you are taking the integration from 0 to n pi. So from 0 to n pi, this will go to 0, and only 1 by 2 will be remaining. So 1 by 2 into d theta, 0 to n pi. So what answer you will get? N pi by 2. So whatever the limit that you are having here, just put n pi by 2 there. That's it. Whatever the limit you are having here, just do the half of that. Did we do this thing somewhere? Yes, we did that thing here. Yeah. So the limit was from 0 to 2 pi. What did the answer I am writing? Pi. 2 pi by 2. So you do not need to mug it up. I am not asking you to mug it up, but in the examination you should have good amount of aptitude that you should be able to solve these very quickly. There you should not be thinking that, sir, okay, sin theta, what is the integration of sin theta, cos theta, and 0 to 2 pi. No. Okay, 0 to 2 pi he is giving sin theta. That means one time period, it will be 0 there. So this is how you need to think in the examination. So this was about our divergence theorem. Now we are going to study about curl and Stokes. Okay, that will come later on. So first we will solve more problems, then curl and Stokes theorem will come. So let's complete till this part, then we will move to this curl and Stokes theorem. Okay, so let's solve this part. Yeah, so there is one note. If in the equation, if a curve is given like x square plus y square is equals to a square, if these kind of curves are given in the question, if x square plus y square, these kind of curves are mentioned, that you need to walk along x square plus y square is equals to a square in some vector field. In some vector field, you need to walk along the curve which is x square plus y square equals to a square in this direction, in anti-clockwise or in clockwise, wherever they are asking. So if these kind of curves are mentioned, then what you are going to do, you will put x equals to a cos theta and y equals to a sin theta. Because if you put x equals to a cos theta here, what you are going to get? A square cos square theta plus a square sin square theta. What will be the answer? A square only. So x equals to a cos theta I will put, y equals to a sin theta I will put. What will be the value of dx I will be getting? Dx I will be getting a sin theta d theta but negative sign. And what is the value of y I will be getting? A cos theta d theta. Okay. So their complete function will be in terms of x square, y square, dx and dy. So now I can replace x with this, y with this, dx with this and dy with this. So I will be able to replace all the variables and all the function will come into some constant which is a and theta. So you will have to put the limit of theta only. So now you need to put the limit of theta. What do you think? Okay, this I am calling theta, so here it should be theta. What do you think? What will be the limit of theta? How will you define the limit of theta? So theta can go from 0 to 2 pi. Look, this is your, that's why I wrote phi here. Don't get confused with sphere. This is in 2D. X, Y, Z. We are talking about this circle. We are not talking about sphere. We are talking about the circle which is on XY plane. This is what we are talking about. So this is your theta, or you can say this is your theta is actually phi here. This theta is phi. Do not get confused. Theta is not the angle made with z axis. It is the angle made with x axis. Are you getting this point? Theta is the angle made with x axis, not with the z axis. So theta is phi only here. I hope you must have understood this point. Okay. So theta is equals to phi. So what will be the limit? So theta can go from 0 to 2 pi, or theta can go from 2 pi to 0. But how will you decide 0 to 2 pi or 2 pi to 0? Look, if you are moving in anti-clockwise direction, that means you are moving like this. So from x-axis angle will increase, no, from 0 to 2 pi. So this is your anti-clockwise and this is your clockwise. We are not mugging up anything. We are just watching the clear concept. If I am going anti-clockwise, that means my theta is increasing from 0 to 2 pi. If I am going clockwise, that means I am going towards 0. This line is going towards 0, right? Okay then, well and good. Yeah. So, and if the function is something like this, if the equation of path, if equation of curve or equation of path is given something like this, then what your x will be? Think about it. X will be alpha plus a cos theta. Say yes or no. And what will be your y? Y will be beta plus a sin theta. Right? You can find dx from here. You can find dy from here. What will be your dx and dy? Alpha is a constant value. So dx will be minus a sin theta d theta. And what will be your dy? A cos theta d theta. Right? And limit of theta, again you can put, again the same limit will be there, 0 to 2 pi, limit 0 to 2 pi if I am going anti-clockwise, and theta will be 2 pi to 0 if you are going clockwise. Well and good. Everything is crystal clear. Let's see a problem. Vector field is given, A dot dl you need to find, where C is the first quadrant of the circle, only the first quadrant of the circle. The thing is, this is your x coordinate, this is your y coordinate. Complete circle will be something like this. Complete circle will be something like this, right? But they are only talking about the first quadrant. So what I'm gonna make? I'm gonna make only the first quadrant circle, which will be this. So they are only talking about this quadrant. So this is 0 0, this is your 1 0, and this is your 0 1. So there is some vector field. I don't know how the field will look like. So a rough field I will make. I'm not sure it will look like this or anything else. So the rough field I am making. So in this rough field, you need to walk along this curve. You need to walk along this curve. Okay. So it is not a closed line integration. Only along this curve you need to walk. Well and good. So what I'm gonna find? X equals to. So what I will do first? I will take an angle made with the x axis. What is that? Theta. I am taking an angle made with x axis, that is theta. So what will be my x? X will be this length is 1. This length is 1 because radius is 1. So x will be 1 cos theta, which I can write as cos theta only, and y will be sin theta. Okay. A dot dl, where C is the in anti-clockwise direction, they are saying you need to walk in anti-clockwise direction. Direction is also mentioned. In this direction you need to walk. Okay. And dx will be what? Minus sin theta d theta, and dy will be what? Cos theta d theta. Well and good. Now in this direction you need to walk. So what will be the limit? Limit of theta. If I am here, then my theta is 0. If I reach here, what will be my theta? 0 to pi. If I am here, my theta is 0, and then I need to walk till this point. So when I reach here, theta will be pi by 2, sorry. Theta will be pi by 2. So from 0 to pi by 2, this is the limit. Now everything will be very easy. What will be your 8 dot dl? What will be your 8 dot dl? I think I would need a page. Okay. So my A is y ax cap plus x ay cap dot dl is dx ax cap plus dy ay cap. So answer will be minus y dx. Look here, x and y both are changing. That's why I took this dl. Are you getting this point? Why my dl is dx ax plus dy ay? Why is that? Because here both are changing. X and y both are changing. So what you are getting, my y dx plus x dy. Now you can solve it using the conventional method as well. In conventional method, how we used to solve? We will make this in the complete term of x only. We will make this complete function in the term of x only or in the terms of y, and then we will take the limit. But your expression will be very complex there, because if you find y from here, what you are going to get? Under root 1 minus x square. Then you do dy, and it will be more complex. So that's why we use these kind of things. Okay, parameter we will put x equals to a cos theta, y equals to a sin theta, to reduce the complexity. Are you getting this point? Otherwise, you can solve by the conventional method as well, like dx dy. If you want to try, you can try it on your own. That dy you find in the terms of x, then you put dy here, and y also you put in terms of x. So y you will put root 1 minus x square. Then you need to integrate it as well. So that will be too much of problems for you. So forget it. We have done what we have done. X equals to cos theta, y equals to sin theta, minus y equals to sin theta. What is the value of dx? Dx is minus sin theta d theta. Dx is minus sin theta d theta plus x dy. So x is cos theta, dy is cos theta. So cos theta dy is cos theta d theta. Okay, and what is the limit of theta? Limit of theta is from 0 to pi by 2. So limit of theta is from 0 to pi by 2. This is your sin square theta d theta plus cos square theta d theta. So from here d theta I can take common, or what I can do, look, there are two ways to solve. 0 to pi by 2 sin square theta d theta plus, forget about it, this would not look that good. So simply you do 0 to pi by 2 sin square theta plus cos square theta into d theta. What is the value of sin square theta plus cos square theta? 1. So what will be the answer? Pi by 2. That's it. Right? The answer is pi by 2. Sin square theta plus cos theta is 1. So d theta 0 to pi by 2. This is the answer. Okay. So these kind of questions are like usually asked in the examination, where if you do by the conventional method, it will be very difficult. But if you put these limits, then it would be more easy for you. There is one more point which I want to address in this kind of particular problems only. There is one more point. You checked this thing, okay, and then you started this analysis. But one more check should be there. What is that? That I will tell you in the next lecture. Okay, we will see this kind of problems again, which will be more difficult. So when you solve by this method as well, then also you will not be able to get answer. Like you will be able to get answer, but calculation will be complex. So at that time, what you need to do? Here calculation was very easy. I could see y is there, x is there, and simple dx dy will come. So what is the expression I am getting? Sin square theta, cos square theta. What if I was getting some cube here? Sin cube theta, cos theta. Then integration of that will be very difficult, no? So how will you solve these kind of problems? So for that I will tell you in the next lecture, because before telling that concept, I need to deal one more small concept. So first we will see the concept of irrotational and conservative field, then we will study that concept. Okay, so that will come later on. So this was the question. Now we are going to study about curl and Stokes theorem. So I will take a break because it's been 40 minutes. So you can also take a break, you can drink some water, and then we will study Stokes theorem and we will solve these problems which we have already solved. But using the Stokes theorem we are going to solve it. Okay then? Yeah, thank you. Yeah, so let's start curl now. So what curl represent? So curl of a vector field F is given by circulation of vector field circulation of vector field, or you can say closed line integration of vector field along a path C or along a curve C per unit very small volume. Sorry, per unit very small surface area. The surface area is the area enclosed by the closed line. Let's just say in this closed line you are working and there is some vector field F. There is some vector field F available. So what will be the closed line integration? What will be the closed line integration? This curve is C. So closed line integration will be F dot dl along the curve C per unit very small surface area. So limit ds tends to 0 per unit very small surface area. This is the surface area I am talking about. So this is the closed line. This is not the open surface. Open surface means this is your open surface. This is your open surface because there is some material in between. But what do you mean by closed line? Closed line means there is no material in between. You just take three closed lines, you just take three open lines and make a closed line. So this is known as closed line. There is no material in between. So this is what curl shows. Not important, but the theorem is important. So what we will get from here, what we are going to get is that if I take ds this side, so first I am going to write f dot dl. F dot dl. What is this C? This is the C. F dot dl is equals to del cross F ds. Here I am not going to put the circle because this is not closed surface. This is not closed surface. This is this is not even open surface. This is not a closed surface. Basically, del cross F ds, where ds is the area enclosed by this closed line. ds shows the area enclosed by closed line. So I should write it actually. Area enclosed by closed line, and here in here also I should have written what is your dv. dv is the volume enclosed by closed surface. Closed surface. Okay. So with the help of closed line, you will enclose some surface area. With the help of closed line, you will enclose some surface area. Here you can see this is the closed line, right? If I need to calculate A dot dl, that means I am calculating closed line integration. So closed line is there. So this will include some area. This will have some area. This is the area it will enclose. Which area? This area it will enclose. But there is no material in between. I only need to work on the line. I am only working on the line. There is no material in between. Okay. So yeah, that's the answer. That's the theorem actually. F dot dl del cross F ds. On ds I need to put a vector sign. I forgot to put a vector sign. So vector sign should also be there. So here I can show S because surface area, whatever the surface area it is enclosing. So we will solve the problems, it will be more clear to you. Again, a very important point, what is that? That it will be applicable when your F, not A, when your F does not tend to indeterminate form 0 by 0 or infinity at any point in the surface enclosed by a closed line. Okay, like let's just say this is the surface that is enclosed by a closed line, and my function and my vector field is x square upon x square plus y square, ax cap, something like that. Then what will happen? At 0 comma 0, at 0 comma 0, this will go to 0 by 0. So if it is going to 0 by 0, at that time you cannot apply this theorem. Are you getting this point? So you need to check all the points, like always we will check 0 comma 0 only, because that is the point where I can get indeterminate form. So if 0 comma 0 is making my function, my vector field function as indeterminate, then that is an issue for me. We will see an example in the next, most probably in the next lecture. So there we will see the theorem will not be applicable. And what is the other condition? Closed line integration has to be there. Other condition is closed line integration. So this is closed line. In divergence theorem, closed surface has to be there. Here closed line has to be there. Well and good. Okay, then let's remove it off. This is of no use. Let's solve some questions. So this question we have already solved. We went from A to B, B to C, C to D and D to A. But now we will solve with the help of theorem. So this is a closed line. It is making a closed line. So how we will solve it? A dot dl, that will be equals to del cross A ds. So first our target is to find del cross A. So how I will find del cross A? I need to make matrices. Sorry, determinant I need to make. So it is in cylindrical coordinate system. So A rho A phi Az, d by d rho, d by d phi, d by dz, and rho cos phi, rho sin phi as well, because rho will be added 0, and 1 by rho. Del cross A will be 1 by rho. Then A rho if I do, this will be 0 only. Rho A phi if I do, this will also be 0. If I do Az, then I will get something. What that would be? Sin phi minus rho sin phi, and then plus. This calculation you should be able to do on your own only. So what you are getting? 1 plus rho by rho. Yeah, 1 by rho is there. Okay, that I have put. 1 plus rho by rho. Okay, yeah. This is what I am getting. Az cap. This is my del cross A. Now what next I need to do? Next I need to do is that del cross A into ds. This is what I need to do. Now the thing is, how would you define ds? So in this question it is very easy, but we will follow one certain method. What we are going to do? We are going to take a small surface like this. Whatever the area it is enclosing this area, right? It is enclosing this area. So in this area I am going to take a small surface. So this is like a strip. I have taken a small strip. Just assume it as my pen. So the pen is here. Now what I'm going to do? I'm going to rotate the pen. On this surface area. Let's just say this was my surface area. And this small strip I have taken. So I will rotate this strip. This was the surface area. I will rotate this strip now. I will rotate this strip on the complete surface. So I will just rotate it. Assuming that I would have taken the strip here. If I would have taken the strip here, then I would have rotated it completely. So now I will rotate it, and then I will see what all things are changing. First, can you tell me one thing, that what is the equation of this plane? Z equals to constant, right? What is the equation of this plane? Z equals to constant, right? Here rho is changing, on this surface rho is changing, phi is changing. Rho is going from 2 to 5 and phi is going from 30 degree to 60 degree. So rho and phi all are changing, but Z equals to constant is there. Although Z equals to 0 is the equation, but Z equals to constant I am writing. So Z equals to constant. This is the equation. So what will be my unit vector? What will be my perpendicular unit vector? Perpendicular unit vector of surface will be Az cap. So what will be my ds? My ds will be rho d phi Az cap. I hope you know this thing, right? D rho d phi dz. So drop dz and these two will come. So this we have already seen. So rho d phi Az cap. This is our ds. So what I am gonna get? That strip example I will take again. That I will take in action again. But let's see what I am gonna get now. Del cross A. And yeah, dz direction also you need to check. So you are moving in this direction. So dz is outward, right? Dz is outward. Az direction. Basically, it could be plus minus Az. No. Why I have taken plus Az? The direction could be plus minus Az, right? It could be going inside as well. It could be coming outward as well. But you need to see in which loop you are going. You are working in this loop. You are working like this. You can see the arrows, right? You can see the arrows. This is how you are working. So if you are working, so use your right hand. So if I am working like this, then my thumb is pointing outward, which is plus Az gap. If this is x, this is y, where will be my z? Z will be coming outward towards me only. So that is plus Az gap. That's why I have taken plus Az gap. Okay. So here I am going to write right hand rule. Right hand rule. Using my right hand, in whatever the loop I need to work, I need to work in this loop. So I will use this and then coming outward. So plus AZ will come. Plus AZ will come. What is my del cross A? This is my del cross A. 1 by rho, 1 plus rho by rho, or I can write it 1 plus 1 by rho. So 1 plus 1 by rho, or let it be 1 plus rho by rho only. 1 plus rho by rho into sin phi AZ cap dot AZ cap, that will be 1 into rho d rho d phi. Now I need to put the limit. That is the important task. So rho and rho will get cancelled. I need to put the limit of rho and phi, because d rho d phi is there. I need to put the limit of rho and phi. So with respect to this strip, this is my strip. Now if I sweep this strip, then how my phi is changing? If I sweep this strip, just try imagining, if you sweep this strip in this direction, how your phi will change from 30 to 60 degree. Someone would say that, sir, I will sweep the strip in this direction, so my phi will change from 60 to 30 degree. But always you will always write down from decreasing to increasing. Okay, lower limit you will always write down first. So from 30 to 60 you will write down. Are you getting this point? A very important point. I will write down always from decreasing to increasing. Okay, from 30 to 60 degree. So what all we have done? First I will calculate del cross A. Del cross A I have calculated. Then I will see ds. What is my ds? Z equals to constant. I am able to recognize the surface. Then I got to know that what is my ds? ds is my rho d rho d phi. Then I have put it here, rho d phi. Then rho and rho is getting cancelled. Now what will be the direction? AZ gap or minus AZ gap? Because two directions are possible. So what will be the direction? I need to see in which loop I am working. So I am working like this. So direction will be plus AZ gap. Now AZ gap into AZ gap. So this is what I am getting, 1 plus rho by rho sin phi rho d phi. Now I need to put the limit. So for putting the limit, I will take a strip. This strip I have taken. So in the direction of phi, if I am working like this, in the direction of phi I am working from 30 to 60 degree. In the direction of rho, how much you are working? Rho is changing from 2 to 5. Look, on this strip, this also you need to take care and this also you need to take care. 30 to 60, 2 to 5. Are you getting this point? Basically, what is this? This is your rho d phi. And what is this? This is your d rho. On this strip, this is your rho d phi and this is your d rho. So what about d rho? D rho is going from 2 to 5 and rho d phi is going from 30 degree to 60 degree. Are you able to get this point or not? This is your rho d phi, this is your d rho. So rho d phi is going from, in rho d phi, the limit will be put for d phi only. So phi is going from 30 degree to 60 degree and rho is going from 2 to 5. And one thing I told you, always we will write down the limit from bottom to top, or from decreasing to increasing, 2 to 5. Well and good. And this, how this came, that also is clear. So is that clear how we are approaching the problem? So this is how you need to solve all the problems. We will see more questions. It will be more clear to you. Okay. So yeah, let's solve now. Rho limit I will put on rho only. Rho limit from 2 to 5. And phi limit will be put on phi only. Sin phi d phi, that will be phi from 30 degree to 60 degree. So if I solve it, rho plus rho square by 2 from 2 to 5, and this will be cos phi, minus cos phi it will be, but I will interchange the limit from 60 to 30 degree. 5 plus 25 by 2 minus 2 minus 2. Yeah. And what is cos 30? Root 3 minus 1 by 2. Because cos 60 is 1 by 2. Yeah, that's correct. So this will become 27 by 4 into root 3 minus 1. That's it. This is the answer. Okay. Just the calculation I am doing. 27 by 4 root 3 minus 1. Now someone will have a doubt that, sir, why did you take this strip? Why I cannot take this strip? Why I cannot take this strip? Certainly you could have taken this strip as well. Okay, in this direction also you could have taken the strip. What will be this value there? D rho. And what will be this value there? What will be this value? Rho d phi. So again the same thing will be happening. D rho is going from 2 to 5 and d phi is going from 30 degree to 60 degree. It can come from 60 to 30 as well, but we will take from 30 to 60. Why is that so? Because I have told you always you need to take the limit from lower to higher, lower to higher. So the same answer would have come. You can take the strip in any direction. Let's solve the next question. Whenever I see this question is there, determine the circulation of B along the path L. L should have been shown. L should have been shown like this. Okay. On the question only it will be shown that this is your path L. So you need to find the circulation of B. So B dot dl you need to find along the path L. So what you can do, whatever the area it is enclosing, so del cross B dot ds. Now your task would be to find del cross B. So I will find del cross B now. So what that would be? Ax cap, ay cap, az cap, del by del x, del by del y, del by del z. xy minus yz into xz. So what you are going to get? Ax cap first, then 0. Here y will come common, so y ax cap plus. Did you get this point? 0 minus, then y would come common. Differentiation of z will be 1 only, so 0 minus minus y, y ax cap. Then what about ay? In ay this will be 0 minus z. And what about az? In az what you are going to 0 minus x, right? 0 minus x. So your del cross B is coming out to be y ax cap minus z ay cap minus x az cap. What will be the equation of this line? What will be the, sorry, no, not equation of line. What will be the equation of this surface or this plane? Y equals to constant, right? The equation will be equation of plane y equals to constant, because in this plane x, y, z, x and z is changing, x, z, but y equals to constant. Y equals to constant. So what will be your ds? You need to write down ds. First write down the direction of ds. Let's do it on the next page, because equation of plane, that is y equals to constant, right? So what will be the direction of ds? That could be plus minus ay cap, which you will pick. So in what loop you are going? In this loop you are going. In this direction I am going, right? I am going into this direction. So direction should be outward. Now it is positive y or negative y? The direction is outward, like basically this is the direction, right? This is the direction. So it will be positive y or negative y? What do you think? Negative y. Why is that so? This is your x, this is your z. What we know? X, y, z. Z cross x will give me y. Z cross x will give me y. Z cross x will give me y. So positive y will be inward. Inward will be positive y and outward will be negative y. So by the axis you need to tell z cross x will give me y. So positive y will be inward and negative y will be outward. And if you are working in this loop, then what is the direction? If you are working in this loop, then the direction is outward, which is minus y. So what you are going to put? What you are going to get? Minus ay cap. Okay. So this is the direction which is minus ay cap. And what will be your surface area? So that will be, here basically x and z are changing. On this surface x and z are changing. So dx dz, or you can think about this as well, dx ax cap plus dy ay cap plus dz az cap. So ay I will drop, then dx into dz, dx into dz ay cap, and minus sign will be there. So what I need to do now, I need to do del cross b dot dl. So del cross b, yeah. So now what I'm gonna do, this dot product with dx dz ay cap, dx dz ay cap, and minus sign is also there, minus sign is also there. So ay cap will be dot product with ay cap only, ay dot ax 0, ay dot az 0. So what you are gonna get, z into dz into dx, that's it. Are you getting this point? Dot product del cross b dot ds, what I am doing, del cross b dot ds, this is what I am doing. So with ay cap I need to do the dot product, so z into dx into dz, or I can write z into dz into dx. Now I need to put the limit. So for putting the limit, what I need to do, I will take a strip. So let's take a strip. In any direction you can take the strip. I am taking the strip like this. So basically this will be your dx and this will be your dz, right? This will be your dx, this will be your dz. Can you tell me one thing, if I need to move this strip, right? I need to move this strip like this. From 0 I will start, from here I will start, from here I will start, and I will move this strip. Or you could have started from here and you could have moved the strip this side as well. Limit always will be put from high, from low to high. Limit will always be from low to high. Now I am moving the strip. So if I move the strip like this, if I am moving the strip like this, then what is the change in the value of x? X is changing from 0 to 1. Say yes or no? X is changing from 0 to 1. So limit of x is going from 0 to 1. Think about it, take your time, how z is changing. dz you need to tell me. Can you say that it is going from 0 to 1 directly? Look, this is how z is changing, no? Here z was this, then this, then this, then this, then this, then like small points are there. Basically 0 to 1. So here dz will be this, then this, then this, then this, then this, then this, then this. Can I write down it is from 0 to 1? What is the equation of this line? This is 1 comma 1 only, right? So the equation of this line is z equals to x. So your z is changing from z equals to 0 to z equals to x on this strip. Here z equals to 0 to z equals to x. Z equals to 0 to z equals to x. Here your z is not fixed. Z is something else, 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 z is something else. In this question, what was the scene? If I am saying that my phi is changing from 60 to 30 degree, then my rho is fixed at all the points. If I am saying that my phi is changing from 60 to 30 degree, if I am moving like this, if I am saying that my phi is changing from 60 to 30 degree, then at all the points my d rho is fixed, which is 2 to 5, 2 to 5, 2 to 5, 2 to 5, 2 to 5. Now in this question, if I am saying that my x is changing from 0 to 1, then my z at all the points my z is not fixed. If I am saying my x is changing from 0 to 1, that at all the points z is not fixed. Z is a function of x. What is the equation of this line? Z equals to x. So z is changing from 0 to z equals to x. Are you getting this point or not? We will take more examples, it will be more clear to you. One fixed value I will take, that in the direction of x, if I am taking, it is changing from 0 to 1. If I am taking in the direction of z, then z was something else here, something else here, something else here. So z is changing from 0 to 1. Sorry, z is changing from 0 to z equals to x. Z is changing from 0 to z equals to x. Z is changing from 0 to z equals to x. 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 Are you getting this point? So this is how I am going to write. In the previous example, what was the scene? If I was saying that my phi is changing from 30 to 60 degree, then my rho was changing from 2 to 5, 2 to 5, 2 to 5, 2 to 5. That's why I wrote constant here 2 to 5. But here this is not the scene. If x is changing from 0 to 1, then z is changing from 0 to some value, 0 to some value that is equal to x, 0 to x, 0 to x, 0 to x. Okay. We will take the strip in the other direction as well, so it will be more clear then. Okay. So yeah, now we need to solve it. So what do you think how you will solve it? Which limit you will solve first, z or x? Since z is a function of x, then first I will solve the limit of z. So whatever that is function of the other variable, first you need to solve that limit, because this is constant value, no? So this will give us a constant answer. So first I need to solve the limit which is the function of some other variable. So first I will solve the limit of z square by 2. So from 0 to x you are going, and then dx is there, and the limit of x is from 0 to 1. The limit of z I have solved. Z into dz will be z square by 2. From 0 to x you are going. So what you are getting? X square by 2 into dx. So limit of x you are going from 0 to 1. So what we are getting? X cube by 6 from 0 to 1. So answer we are getting is 1 by 6. Okay. So this is the answer. Now let's take the other strip. I will add a page and we'll take the different strip. Okay. So let's make the diagram first. Yeah, so this was your 0, 0, 0, 1, 1, 1. Yeah. So now if I take this strip, okay, this direction is your z, this direction is your x, this is your z, this is your x. Okay. So this small length, this will be your dz and this will be your dx, right? Okay. Now if I say I need to move this strip, like this I can move, or like this I can move. I need to move this strip. So if I say my z is changing from 0 to 1, I am starting from here, z is changing from 0 to 1, then how my x is changing? If I am saying that my z is changing from 0 to 1, then how my x is changing? What is the value of x here? X is fixed, x equals to 1 here. This is fixed, right? X equals to 1. On this point, x equals to 1, which is fixed. Wait a second. Here z is equals to 1. No, wait a second. Yeah, sorry. This was x equals to 1 and z equals to 0. Sorry, this was x equals to 1 and z equals to 0. So on this is how the strip is moving, you know. I need to find how my x is changing. So x equals to 1 is fixed here. But what is x here? X equals to z is. What is the equation of this line? X equals to z. So if I say I am changing my z, z is going from 1 to 0. Z is going from 1 to 0. I started from here. I am increasing this in the z. I am increasing this strip in the direction of z. Again I am saying I am increasing this strip in the direction of z. Then how it is increasing? From 0 to 1. So z is going from 0 to 1. What about x? What about x? What about x? So x is fixed here, that is 1. X is fixed, that is 1. So x is going from 1 to x equals to z. 1 to z, you can say 1 to x equals to z. Now someone will have the doubt, sir, that sir, which one we will put, 1 to z or z to 1? So we will, at the lower limit, always we will put the constant value. So from 1 to z we are going. Okay. So if I write down now what I was calculating, del cross b dot ds. What was my del cross b? z into dz. Till this point everything will be same, just the limit of these values will come. So z is changing from 0 to 1, then x is changing from, so always lower limit will be constant, 1 to x equals to z. So which limit you will solve first? Which limit you will solve first? X limit you will solve first. X equals to 1. Yeah. So x limit I will solve first. So what I'm gonna get? Basically the integration will be z x from 1 to z, and then limit of z will be there as it is from 0 to 1 z into dz. So what you are getting? 0 to 1 z minus 1 into z into dz. Z minus 1 into z into dz. So 0 to 1 z square minus z into dz. So z cube by 3 minus z square by 2. Okay, 0 to 1. So 1 by 3 minus 1 by 2. That will be 1 by 6. Are you getting the point how we are writing down the answer? This is one of the other point, that always lower limit will be put constant, higher limit will be the function. Okay, and which limit we will solve first? That is pretty obvious, because we need to solve the limit which is the function of some other variable, because this limit will give us constant only. So we will not solve this limit first, we will solve this limit first. Is that clear to you? This was a closed path, this was the direction, this was our closed path. We could have taken the strip in any direction. First we took the strip in this direction, so we were moving the strip in x direction, like with respect to x we were moving. So x was going from 0 to 1, but how z was changing? Z was changing. So if x is some value, then z is function of x only, z is function of x only, z is not constant. Same thing is happening here. If I am taking the strip in this direction, so along the z I am moving it, along the z I am moving it, along z. So z is changing from 0 to 1, z is changing from 0 to 1, z is changing from 0 to 1, but x is changing from x equals to 1 is fixed here, x is changing from x equals to 1 to x equals to z, x equals to 1 to x equals to z. Is that clear? Let's see more examples, and by more and more method we will solve. Okay, so this particular diagram I need to copy again and again. So I will copy it firstly. This has been copied. So try solving this question first. Basically that f dot dl you can find on your own. I will only calculate del cross f dot ds. What I will calculate? Del cross f dot ds. So first let's calculate del cross f. Because this line integration I have already told you. How will you calculate? You go from here to here, then here to, okay, what is the path? This is the path. Okay, so you go from here to here, then here to here, then here to here. You go from, let's just say this point I am calling point A, B, C. So how will you calculate this value? F dot dl. Very easy. A to B, F dot dl, dl1 I can say, plus B to C, F dot dl2 I will say, and then C to A, F dot dl3 I will say. So in that manner you need to move, you will get the answer. But I will solve it using the Stokes theorem. So that is my target. So let's solve it using the Stokes theorem. So del cross F. Ey cap, Az cap, del by del x, del by del y, and del by del z. X square y minus y 0. Del cross F. Ax will be 0, Ay will be 0, and Az. Yeah. So Az will give us some answer. What it will give us? So in case of Az, 0, x square will be constant, so minus x square. So this is your minus x square Az cap. Again let's see it. 0, 0, Az cap. So 0 minus x square will be common, so minus x square, so minus x square Az cap. Values I have written correctly, yeah. So this is your del cross f. ds, what is your ds? ds is z equals to constant or z equals to c. So what is your ds? Z equals to constant is the surface, z equals to constant is the surface, so it would be dx into dy. Now tell me what will be the direction? In which direction you are moving? You are moving in this direction, right? This is how I am moving it. So if I am moving in this direction, then my thumb is going inside. Thumb is going inside. So direction is minus Az cap. So what has become your equation? Your equation has become del cross f dot ds. Okay. That has become as x square dx dy, because az cap minus minus will be get cancelled, az cap will be 1, so x square dx dy, so x square dx dy. Now I need to put the limit. Strip I will choose, let's just say 99% of the chance is there you will choose the strip like this, right? So this is the strip I have chosen. So I will move the strip like this, I will move the strip along x, so I can see that my x is going from 0 to 2. I am moving the strip along x, so I can see that my x is going from 0 to 2. How my y is going? Y is something else here, 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 something else here. Can I say what is the equation of this line? What is the equation of this line? Y equals to x. Say yes or no. What is the equation of this line? You can calculate, slope is minus 1 only, and it will cut y axis at 2. So 2 minus x. The slope of this line is 2 minus x. Are you getting this point? Slope of this line is, sorry, equation of this line is y equals to x. Slope and equation of this line is y equals to 2 minus x. You can check. If you put x equals to 2 here, y will be 0. If you put x equals to 1 here, y will be 1. This is very basic mathematics. In 12th class, you must have studied it. The equation of the line you can find. Certainly, you can find equation of line. So if I move the strip, so x is changing from 0 to 2, but y will be broken in two limits, because from here to here, y is changing as 0 to x. This is your dx, this is your dy. So I am moving along x. So I am saying that x is going from 0 to 2, but how y is going? Y is going from 0 to x, but till a to b only. Are you getting this point? And it is going from 0 to 2 minus x. It is going from 0 to 2 minus x from b to c. This is how you are moving, no? So how will your strip go? Like this, like this, like this, like this, like this, then like this, like this, like this. This was your strip. You are starting from here. You are starting from here. So this was your strip. This way, this way, this way, this way, this way, then this way, this way, this way, this way, this way, this way, this way. Say yes or no. So this is how your strip was going. So y was from 0 to x, then it was from 2 to, from 0 to 2 minus x. Is that clear to you? We will solve it by one more method. It will become more clear. I hope I am giving enough examples. So here we have to break the limits. So how will I break it? So when x is going from 0 to 1, y is going from 0 to x, x square dx dy. And when x is going from 1 to 2, y is going from 0 to x minus 2, x square dx dy. Which limit we will solve first? 0 to x minus 2? No, 2 minus x. That's what I was thinking. Y is going from 0 to 2 minus x. Okay. So which limit we will solve first? This one, right? So the limit of y we will solve first. So dy will be there. So this will be x only. So what you are going to get? Basically, dy, integration of dy will be what? Y only. And y is going from 0 to x. And then x square dx. X is going from 0 to 1 only. What will be the solution of this? X minus 0. That will become x only. So this will become x only. So x dot x square, that will be x cube dx. X cube dx plus, let's solve this one. So x limit is 1 to 2, this we are not solving, we are solving the limit of y. So y is going from 0 to 2 minus x. So 2 minus x into x square dx. So this will be 2x square minus x cube. 2x square minus x cube. 2x square minus x cube. Okay. So x to the power 4 by 4 from 0 to 1 plus 2x to the power 3 by 3 minus x to the power 4 by 4 from 1 to 2. Again, let's check all the calculation. From 2 minus x x square, 2x square minus x cube, 2x to the power 3 by 3 minus x to the power 4 by 4. Yeah, okay. So let's do the calculation now. So 1 by 4 plus, this will be 1 by 4 minus 0. Now what about this? So this will be 16 by 3. 2 here I will put, so 2 to the power 4, 16 by 3 minus 16 by 4 minus 2 by 3 plus 1 by 4. Okay, so 1 by 4 plus 14 by 3 minus 15 by 4. Am I doing it correctly or there is some calculation mistake? Okay, so I will do it using the calculator and then I will write down the answer. Okay, you can also do it using the calculator. Yeah, so after solving it, you are getting 1.167. Okay, very easy, 1.167 you will get. Now method 2, what will be the method 2? Now I can take the strip in horizontal direction. So if I take the strip in horizontal direction, in this manner if I take the strip, then what will be the limits? So if I am taking the strip in horizontal direction, so now how I will move the strip? I will move the strip along y axis. I am moving the strip along y axis. So this is your method 2. So what will be the limit of y? Y is going from 0 to 1. What about x? I am moving along y axis, so x is going from this value to this value. X, basically x is going from here to here, here to here, here to here. So what is the value of x here? X equals to y. And what is the value of x here? 2 minus y. The equation is x equals to 2 minus y, because here I know the equation is y equals to 2 minus x, so x is equals to 2 minus y. So the equation is x equals to 2 minus y. Now you need to take the limit. So you will take the limit from y to 2 minus y, or you will take the limit from 2 minus y to y. Think about it. From where to where you will take the limit? So tell me one thing. In this particular graph, what is the range of y? The value of y is changing from 0 to 1. The value of y is changing from 0 to 1. Say yes or no. In 0 to 1, which one is larger? Y is larger or 2 minus 1? 2 minus y is larger. In the range y is equals to 0 to 1. In the range y belongs to 0 to 1, y is larger or 2 minus y is larger? So 2 minus y is larger than y. How is that so? How is that so? Look, y is from 0 to 1. So if I put y equals to 0, then what will be the value of y? 0. What will be the value of 2 minus y? 2. So 2 minus y is larger. If I put y equals to 0.5, what is the value of y? 0.5. What is the value of 2 minus 0.5? 1.5. So which is larger? 2 minus y is larger. So always I need to write down the limit from lower value to higher value. This is what I told. If one of the constant I am getting, then there is no issue. Here I wrote from 0 to x, because one value was constant. So from constant to variable I will write. But here both are variable. So which one I will write downward? The one which is low. So from 0 to 1, which is low? Y is low. So from y to 2 minus y I will write. Did you get this point or not? Okay. Because in the range 0 to 1, because in this particular loop, on this particular path, your value of y is from 0 to 1. That means your range should be from y to 2 minus y. Well and good. Okay, this has to be there. Yeah, so now I will do the integration, because x value I have written, y value I have written. So what will be the value that I was thinking? So it was x square dx dy. So value of y is from 0 to 1. value of x is from y to 2 minus y. So which limit I will be solving first? I will be solving the limit of x first. I will solving the limit of x first because that is variable. So x cube by 3 from y to 2 minus y into dy. So limit of y is from 0 to 1. So I can take 1 by 3 outward, and it would be limit of y from 0 to 1, 2 minus y cube into dy. 2 minus y cube, and the lower limit is y as well, no? So 2 minus y cube minus y, 2 minus y cube minus y cube into dy. This is what I am getting. Okay, so if I solve it, what I am going to get? 1 by 3, then 2 minus y to the power 4 by 4 and 1 negative sign minus y to the power 4 by 4, and limit is from 0 to 1. Now what I can do is that I am solving it here, okay, or what I can do is that I will just pick this upward. I'll just pick this upward, and now I can solve. So what I am going to do is that I am add this negative sign and will change the limit. So 1 by 12 y to the power 4 plus 2 minus y to the power 4, and limit I have changed from 1 to 0. So 1 by 12. If I put 0, then this is 0, this is to the power 4, 16 minus 1 minus 1. So what I am getting? 14 by 12. And what is 14 by 12? That is 1.16 only, I guess. 14 by 12. Yeah, 1.167. So this is the answer. So calculation you need to take care. Also you need to take care of the limit as well. So this, in this manner as well, you could have solved it. So I will always try to take only one limit. Here I need to break the limit, so that I would try to avoid. Okay. Now let's solve this question. Is it framing a closed loop? Yes. Closed loop is there. That means a closed line integration is there. Closed line integration is there. Okay. You can find out del cross f as well. You can find out del cross f as well. But can you find out ds? It would be very tough. Which is your ds? This is your ds. Can you see it? Can you see the structure? Like, what can you see? This line, this line, this line, and this line. Where will be ds pointing? It would be very tough to find. The ds can be actually found, but on 3D, are you able to visualize where will be ds? No, very tough it is, right? So in these kind of problems, I will try to avoid applying Stokes theorem. Stokes theorem is applicable. What I am saying is that Stokes theorem is applicable here. Theorem is applicable, but this is tough. So better solve with since it is tough to find ds vector here, better we should solve with open line integration. Okay, so yes, the theorem is applicable, but the path is the closed path, or I would say the closed line is enclosing that kind of area which is very tough to find. So that's why I will use line integration here. So from where to where I will walk? Let's just say this point is A. So that's why I said that sometimes theorem will be applicable, but again you will not be able to find ds. So if you are not able to find, always we have one chance. What is that? That I can apply line integration, A to B, B to C, C to D, and D to A. Okay. So what I need to find? F dot dl I need to find. I need to find f dot dl. So how I can break it? F dot dl1 plus F dot dl2 plus F dot dl3 plus F dot dl4. A to B I will go, B to C, C to D, D to A. Okay. So first let's talk about dl1. So in dl1 what is changing? Only x is changing, right? Here only x is changing. So dx ax cap. Here only x is changing, so dl1 will be dx ax cap, right? Dx ax cap. So what I will get? F dot dl1. So F dot dl1 would be x square dx. X square dx. Now from where to where we are going? I am moving from here to here. So 1 to 0 I am going. So for here 1 to 0 I am going. Here you will not say that sir from 0 to 1 I will write. No. Only in the surface I have told that you will write down the limit from lower to higher. Here you need to see the path where you are walking. From 1 to 0 I am going. From 1 to 0 I am going. So x cube by 3. 1 to 0. So minus 1 by 3. And this is one of the answer. dl1. Let's talk about dl2 now. This is your dl2. What is changing in dl2? What is changing? Y is changing. So dy ay cap. Wait a second, there is some error. Yeah. So it would be minus ax cap, no? Dx minus ax cap, because we are moving in the minus x direction. Will I put minus ax cap there? No, I told you, you will not put minus ax cap because limit will take care of that, right? So a lot of times student will have this doubt that sir, dx minus ax cap. No, you are saying that I am moving in ax direction only, but I am going from 1 to 0. So limit will take care. Always you need to write down this positive only. Okay. If I write down minus ax, then my limit will be from 0 to 1, not from 1 to 0. Are you getting this point? I hope this is clear to you. So increasing, decreasing, we will not see. This I already told in the last lecture, so people might have forgot it. So now you remember it, okay? So always you just need to check, okay, y is changing, so dy ay cap, that's it. Don't even think about minus. Minus I am only thinking when I am writing about ds, that's it. When I was writing about ds, here when I was writing about ds, then only I need to see the direction, whether it is plus az or minus az. Otherwise, for length, I do not even need to think of direction. In any question, if I am using length, then I do not need to think the direction. Always I will write positive because limit will take care. But here I will think about the direction. I am thinking about the direction, but here I am not thinking about the limit. Why I am not thinking about the limit? Because I know limit I will put from low to high only. But I have taken care of the direction here. In the line integration, what you are doing? You are not taking care of the direction, but you are taking care of the limit. Here you are not taking care of the limit, but you are taking care of the direction. Okay. In surface, we need to take care of the direction. That's it. So if I am taking care of the direction, I will not take care of the limit. From low to high only I will write. And if I am not taking care of the direction, then I need to take care of the limit, because here it is completely visible that I am going from here to here. So from 1 to 0, I can take care. From 0 to 1, I am going. Pretty easy. So if I am moving here, so what I am going to write? F dot dl2 from 0 to 1, right? So dot ay xz ay minus xz dy. Okay, you will multiply with ay vector only, ay unit vector only. So minus xz ay. Here, what is the value of x? What is the value of z? 0. You are moving on y axis only. You are moving on y axis. So what is the value of z? 0. What is the value of x? 0. On this line, what is the value of x and z? Always 0, no? 0, 0, 0, 0, always 0. So x equals to 0 and z is also equals to 0. Both are 0. So what will be the value of this integration? 0 only. 0 into 0 will be 0. So this is the other answer. Let's see the third one. dl3. What will be dl3? dl3. What all things are changing? What do you think? Here your y is constant. Y is at 1. This is also at 1. X, Y, Z you have written. Y is constant. What all things are changing? Only X and Z are changing. X and Z are changing. Are you getting this point or not? Forget about it. If this line is given to you, this point is 1, 1, 1, other point is 0, 1, 0. 1, 1, 1, other point is 0, 1, 0. Can you write down the equation of this line? Yes. X minus x1 divided by, I will put x1 this as this point. X minus x1 divided by x2 minus x1, 1 minus 0. That would be x minus x1 divided by x2 minus x1, 1 minus 0 would be 1. Y minus y1 divided by y2 minus y1. Z minus z1 divided by z2 minus z1. And that will be equals to some lambda. So x is equals to lambda, y is equals to 1 and z is equals to lambda. Okay. So x and z are changing but y is constant, that is equals to 1. So this is the equation of the line. This is the equation of the line. X equals to lambda, y is equals to 1 and z equals to lambda. This is the equation of the line. I told this thing in the very first lecture of EMFT. When you were studying vector algebra, I told you these equations will be used somewhere. So here it is used. Okay. So from here, what did you get to know? What is the equation of the line? What is the equation of the line? X equals to z. The equation of the line is x equals to z. X equals to lambda and z equals to lambda. So from here, what can you conclude? X equals to z. Or how you can think that here y is fixed. So isn't it like that in yz, in xz plane, this line is there in xz plane only. It is parallel to xz plane. Y is 1 which is fixed, and this line is there which is parallel to xz plane, and the equation will be z equals to x. Here also z is equals to x, 0, 0, 0, 0. Equation is z equals to x. So the equation was important, but what will be your DL3? What all things are changing? Z is changing and x is changing. So dx ax cap plus dz az cap. Here what do I know? That x is equals to z. So dx is equals to dz. So if I need to write f dot dl3, so what I'm gonna do? So x square dx minus y square dz. X square dx minus y square dz, right? X square dx minus y square dz, because what is my dl3? Dx ax cap plus dz az cap. Here y is fixed which is equals to 1. Y is fixed at 1. So value of y I will put 1. And what I am gonna do, I will change the dz value as well. So x square dx remains as it is. Y I am gonna put as 1 and dz will be changed to dx because dz is equals to dx. And x is changing from 0 to 1, right? X is changing from 0 to 1 only, no? So here x was 0, here x is becoming 1. So x is changing from 0 to 1. So limit is 0 to 1 and this is how I am replacing it. Is that clear to you or not? This is my DL3, dx ax cap plus dz az cap. Y is equals to 1, that is fixed. Till this point everything is clear because x and z both are changing, y is fixed. Now from the equation I get to know that x is equals to z here. So dx is equals to dz here. No doubt about that. Dx is equals to dz. Or how you could have done it. X equals to lambda and z equals to lambda. So what you would have done? Dx equals to d lambda and dz equals to d lambda. So dx is equals to dz. From here also you could have done it, right? No doubt about it. Well and good. So dx equals to dz. Now I need to take this in one variable only, because I have told this thing in the last lecture. If you remember the last lecture, all should be taken in one variable. Y is equals to 1, that I have put dz dx. Dx dx x square dx. Okay. So x cube by 3 minus x from 0 to 1. So that would be minus 2 by 3. Okay. Think about DL4 on your own. Should be able to think. DL4. This is the fourth one. DL4. So what all things are changing in DL4? what is constant? X is constant. What all things are changing? dy and dz, y and z are changing. So dy ay cap plus dz az cap. Where you can either you can write down the equation, or you can think is that x is fixed. So this line is parallel to yz plane. The line is parallel to yz plane, and the equation is y is equals to z. Here I can think that x is equals to 1, that is fixed, and the equation here is y is equals to z. So dy is equals to dz. And if I need to write f dot dl4, what I am gonna get? So what you are gonna get is that, so xz dy minus y square dz, xz dy minus y square dz, minus y square dz, x is equals to 1. So what I am gonna do is that I am gonna keep all in terms of y. And what is the limit of y? Limit of y is going from 1 to 0. Limit of y is going from 1 to 0. Y is going from 1 to 0. Now x is 1, minus z is equals to y minus dy minus y square dy. Okay, so minus sign will come outward, y square by 2 plus y cube by 3 from 1 to 0. So what you are getting? 1 by 3 plus 1 by 2. 1 by 3 plus 1 by 2. So 6, 5 by 6 minus 5 by 6, and positive sign will come because, so 5 by 6. You can solve the integration 5 by 6. So what is the final answer? 5 by 6 minus 1 by 3 minus 2 by 3. Okay, so final answer is f dot dl, that is minus 1 by 3 plus 0 minus 1 by 3 plus 0 minus 2 by 3 plus 5 by 6. This integration you must have solved it. Here there is minus sign, so you can interchange the limit from 0 to 1 it can go. So this is minus 1, so 5 by 6 minus 1, so minus 1 by 6. So this is the answer, f dot dl. Okay, yeah, so that's it about this lecture. This was the answer. I hope you must have understood the theorems. Is there any question left? No. I hope you must have understood the theorem, what is the, how you can solve the problems. Mostly it is mathematics only, but useful for you, and there is 100% chance, like I am saying 100% question will come from it in ECE, electrical and instrumentation. 100% I am saying. Today you can write on paper, and in the examination certainly you are going to see the question from it. 100%, at least for 1 mark or 2 mark. In 2022 I remember it came for 4 marks. So that can also happen. So 100% these kind of questions from vector calculus are asked. There is no one who can stop it. So I hope you are building up the concept. We will see one more video, there we can see more problems. So we will see more problems, and some more concepts also we will see, like irrotational, solenoidal, these kind of concepts are also left. So that concept also we will see, and some problems also we will see. After that you will get good amount of confidence in this particular chapter. Okay then, thank you very much. If you are finding it helpful, then you can write down in the comment section. Thank you.